let's get started. So what were we learning in the last class? We were learning permutations, combinations, and a little bit of probability. So today will be our last class for on the same topic, which is on permutation, combination, and probability. And essentially, what we'll do is we'll use the concepts of permutation and combinations for solving probability problems. Okay. So I just sent a message to you guys in the WhatsApp group. Mentioning what all we are going to learn today. Ananya also joined. Hey Ananya. So just a quick recap of what we have done before. Just to help you guys recall, when we talk about permutation, we learn a formula n permutation k. This equals factorial n divided by n minus k. And we all learned how this formula comes into existence, and how this formula came into existence. And when we talk about permutation, it's nothing but just a method for arranging certain things. So if you have n options to fill k slots, this is the formula that we derived, and we saw how it happens. Similarly, when you talk about combinations, we learned n combination k equals nothing but factorial n divided by factorial n minus k multiplied by factorial k. And again, when you talk about combination, this is the same stuff as permutation, only difference being in permutation the order matters. Let's say if you have A, B and C, three things, this is considered one combination, and you don't, well, this three is considered one combination. Even if you have B, A, C, C, A, B and other options, all these things together are considered one combination. That's why you see one extra division here, which limits the number of, the total outcome for, in case of combination. So summary is, if you talk about permutation, you are arranging certain things and the order matters. In case of combination, the order doesn't matter. That's the primary difference. And that's why when you look at combination, you're actually grouping the set as one, so that the overall number of combinations are less. So ABC and BAC are considered one combination. When you look at it as a permutation, ABC and BAC are two different things. This part is okay, right, so far? I know for Anush it's the first class, so he still might have some confusion, some doubts. But for everybody else who were there in the previous classes, I'm assuming that this part is understood. Any questions so far? Anything that is not clear to you guys? Can I assume a silence as a no or a yes?
It makes sense.
Okay. So now let's look at the next thing, that is probability. So when you say probability is nothing but something which is again as a chance. What is the probability of me getting $2 million a month as salary? This is not a probability. This is based on my skills. So that will not be a probability. Probability is something where you say that, okay, what is the total number of events versus, a chance of one event happening versus the total number of events. So that is how you look at probability. So we have talked about probability in the previous classes, but let's do a quick recap. Let's say if I say I'm tossing two coins, what is the probability of getting head and head? We tried solving that in different ways, but we're just doing a quick recall of how you calculate probability, and then we'll try relating that with permutation and combination understanding that we have built so far. But before I move on, Anush, any basic question, any doubt that you have with respect to probability, permutation, combination, which you would want to understand as a jump start, just let me know.
Okay. I'm pretty good right now.
You're good? Okay.
Yeah.
Alright. So when you talk about probability, we all know that probability means likelihood of one event versus the total number of events. That's the going in position for understanding probability. So let's use that concept for solving few problems with respect to probability. Now, if you look at the topics that I had sent to you guys in WhatsApp, what I had mentioned was we'll talk about practicing a few combination probability problems, something like picking up certain cards from a pack and then Mega Million jackpot, right? I mean, we all dream of a situation when we win a jackpot worth millions of dollars and then we don't have to do anything, right? I mean, I hope I'm not the only one who thinks that way. Majority of the people, right? We think that, okay, what if I win $50 million and then I have to do nothing for the rest of my life, right? So we'll try understanding that mathematically to see how feasible, how viable, how practical it is to assume that I just need to win a $1 million lottery and then we're done. Yeah. So let's look at certain problems, and I would want you guys to be with me, participate, engage, and pump in more ideas, your thoughts, so that we are able to apply that in real time problems. So let's look at a situation. I'm saying that we have a pack of cards, meaning we have, let's say, 36 cards. Okay, so 36 cards meaning I have four varieties. Again, diamond, spade, what are two other things? Ritika, Savya, do you guys remember? What are the other two variants? When you look at the pack of cards, we call that one is this one, diamond. Other one is called spade, which is like this. And then you have something like this. And then you have, oh, diamond, spade, hearts, and this one more. Who remembers that?
It's clubs.
Clubs, yeah. Okay. So let's say you have a pack of cards with 40 cards, let's say. I'm discounting Jack, Queen and King. Kings, okay. So let's say we have a pack of cards with 40 cards. So A to 10, A to 10, A to 10, A to 10 of all the four parts of the pack. Okay. Now I'm saying if I have to distribute 9 cards each to 4 of the players. Okay. So I'm distributing 9 cards each. To 4 players. What is the probability of getting 4 A's in one group? So in one group of 9, what is the probability of getting 4 A's? So before I try solving this, my question to you guys is, you have a pack of cards with 40 cards, all A to 10, 4 clubs, spade, diamond and heart. And then you're distributing 9 cards. Out of 40, you're making a group of 9 cards and distributing that to 4 players. What is the probability of getting all 4 A's from each of the group in one of the groups? What will be your approach? What exactly you can think of? Any thoughts? Yes, it's ready.
So it would be 9 out
Sorry, say that again.
of 9 out of 40.
I wish that was such an easy question. Okay, any other thought? Yes, Ritika. Yeah, sorry, Chris, sir. You go ahead.
How many A's are in a deck?
I said that no, there are 40 cards, there are 4 A's. Yeah, so every A to 10, right? Let's say this is heart, A to 10. So there's one A here. Let's say this is spade, A to 10. So there's another A here. Then this is club, one A here. Spade, one A here. So there are total 4 A's. So what we are saying, what we are trying to find out is, what is the possibility of, and we are out of the 40 cards, we are distributing 9 cards each to the 4 players that we have. So what is the probability? What is the probability of getting 4 A's in one group? So how would you approach? I'm just curious to understand what would be your approach. If somebody can tell me the approach, then I will try solving it. Don't worry about all permutation, combination, everything. Tell me, how do you find probability? I mean, give it a try, guys. I mean, it's okay. Being wrong is perfectly fine. Otherwise, I'll give you guys a punchline, right? Failures are the pillars of success. Fail once. Yes, Anush.
Would you find the probability of getting 1A and then multiply it by itself 4 times?
Probably not. But yeah, thanks for trying. I mean, see, again, I want you guys to think. I'm trying to force you guys to think, because if you think, then we can correct. Okay, my thinking was probably going the wrong direction. Yes, Ritika.
So for probability, the most basic I could think of was like the number of favorable outcomes over the number of total outcomes.
Yes, that is the starting point, and that is your thumb rule. That will not change. Okay. Now, how you will find out the probable outcomes versus the total number of outcomes, that we will deliberate. But yeah, you started with the right on the right note. That any probability that you have to talk about, you have to think about, okay, what is the probable outcome for that given situation versus the total number of outcome. That's your starting point. Okay, what next?
Figuring out what our favorable outcomes is.
Right. So remember one thing. Whenever you are being asked to solve a probability question or a problem, your first point would be, what is the total number of favorable outcome versus what is the total number of outcomes. That's what you have to find out. So you divide the total number of favorable outcome by, so probability equals number of favorable outcome by total outcome. Total outcome. That would be our going in position. So yeah, thanks Ritika for giving me the jump start. Now let's look at this. Based on whatever we have learned so far, we'll try relating that. So let me create some space here on the board so that we have enough real estate. Alright. So it's very simple. So far we know that okay, there are 40 cards in the pack, 10 each, every pack, and every pack has A to 10. So we have this many, A to 10. Okay. Now we have to find out what is the total number of favorable outcome and what is the total number of outcome. So first of all, what is the total number of outcome here in this case? We have to find out group of 9 cards from 40. So we have to find out combination of 9 cards out of 40. So we are talking about essentially this. We are trying to find out how many group of 9 cards we can make with 40 cards or a pack of 40 cards. Is that fine? This is my total number of outcome, meaning all the different groups that are of 9 cards I can make with 40 cards. This will be my total number of outcomes. Is that part okay?
Yes, sir.
So I'm kind of breaking the problem. We have to find out 2 things. Number of favorable outcome divided by total number of outcome. This is my total number of outcome. These are the ways in which I can form a group of 9 cards. Okay. So let's look at this. What this says. So this is factorial 40 divided by factorial 40 minus 9 into factorial 9. This formula you guys remember, right? N combination k equals factorial n divided by factorial n minus k multiplied by factorial k. Yeah? So I'll just apply the same formula here. So this gives me total number of outcomes, which is nothing but this is factorial 40 divided by factorial 31 into factorial 9, which equals, so this is 40 by factorial 40 or factorial 31 will be like 32 into 33 into 34 into 35 into 36 into 40. Let me write it also. 38, 39 into 40. And so these two are taken care. So 31, 30, so 32, 33, 34, 35 up to 40. This is your, after dividing factorial 40 by factorial 31. And then factorial 9 is nothing but 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2. So 9 4 ja 36, I can knock this 2 off. 7 5 ja 35, I can knock this off. And then, okay, 6 3 ja 18, 6 3 ja 18, 2 ja 36. So I can knock off, 36 is already gone. Okay, 6 3 2, 3 2 ja 6. Okay, 3 11 and 2 6 are 12, 2 16, then I create some mess. So forget about this. We'll come to this one, okay? So here, whatever we have, let me not do it this way. 9 8 7 7 6 5 4 3 2. Let it be. Let it like this, okay? Let me not do anything here so far. Or whatever I can do easily. 8 4 ja 32. I can knock up this one. 7 5 ja 35. I can knock up this one. And then 9 this 3 into 2. So 9 4 ja 36. I can knock these two off. Then I'm left with 3 and 3 6. So 3 11 ja 33 and 3. Okay. So whatever we have here now, 3 into 13. So this gives you some value. 11 into 34 into 37 into 38 into 40 into 13. I got this value. So we'll hold it there. Now this is my total number of outcome, whatever it is. I mean, even if I made a mistake, but at least you know what exactly we're trying to calculate. Now what is the total number of favorable outcome? Just by looking at this, we are talking about what is the total number of favorable outcome. Meaning you have, let's say you're talking about one group having all 4 A's. That means 6, 7, 8, 9. So this is one group having 4 A's. You only have 4 A's here. I mean, there's only one situation in which you can fill 4 A's. You have to fill 9 positions, and there's only one situation when you can put all 4 A's in a group. So this is only one possibility. There's no juggling, no manipulation that you can do. And since the order doesn't matter, so it becomes even simpler that, okay, out of the 9 positions that you have to fill, in which you will have all 4 A's, this is only one scenario. There is no second scenario. Now, remaining 5 positions, you can fill in a certain ways. That's what we'll try to figure out. You have total 40 cards, and you are talking about a favorable situation where you have all 4 A's. So this is only one situation where you will have all 4 A's. Remaining 5 positions only you can play around with. So out of 40 cards, you have picked up 4 A's. Then you are left with only 36 cards. First position you can fill in 36 ways. I mean, first on the fifth position, let's say 7, 8, 9. After filling the fifth position, the sixth position you can fill in 35 ways because you exhausted one more card here. Then you can do this, then you can do this, and then you can do this. So the total number of ways in which you can have all the 4 A's in one group is only this. So this is your favorable condition. Let me use the moment of silence here to understand if whatever I did here with respect to finding the favorable condition, is that understandable so far or not? Anybody having any doubt, please let me know. Yes, Ishwari. You understand this? Okay. Yeah, Ishwari, go ahead.
I didn't get exactly how you found out your favorable outcomes.
Okay, so let's do one thing. Let me take out everything from this board and then only retain this number here. So this is my total number of outcome that we have found out, okay? I'm assuming whatever calculation I did not miss or overlook anything, but let's assume that this is correct. 40 into 13. So this is my total number of outcomes, okay? This one we have found so far. Let's go back to finding out the favorable condition and how do we arrive at that. So now let's look at this situation. What we are trying to find out, we are trying to find out the probability of having one group with all 4 A's. That means one person, let's say if 4 of us are playing cards, I am one of the player, okay, who gets all 4 A's. Now let's say if Ananya is another player who is distributing the cards. Yes, Chris.
Wait, I just had a question. Before you move on to explain the favorable outcome, the multiplication, like the 11 times 34 and all that, that's the total number of outcomes.
This is the total number of outcomes, yeah. That's what we found by doing 40CN. So we are trying to find out a combination of 9 cards, or the ways in which we can form group of 9 cards, right? One of those groups will be given to all the players, right? So this is my combination formula, which was nothing but factorial 40 divided by factorial 40 minus 9 multiplied by factorial 9. This is my combination formula. This just tells me how many ways I can form a group of 9 cards with 40 cards. Yeah, and this only gave me this result, hoping that I did not mess with any other calculation when I was doing it. Yeah, is that clear? Yeah.
Yeah, thank you.
Now let's say Ananya is distributing the cards, and there are 2 more players. Let's say since Chris is talking, Chris and Ishwari are 2 other players. So Ananya is distributing the card, and she's trying to find out what is the possibility of me getting all 4 A's in my group. And interestingly, if it's me, the lucky one, who gets all the 4 A's in my 9 cards, that means these 4 positions are filled. And that's the only way she can do it, because she has only 4 A's and she has given all the A's to me. So, how many ways she can distribute A's in one group, be it me or Ishwari or Chris or herself? There's only one way. These 4 positions can be filled in only one way. There is no second option. Yeah. Now, what is the probability of filling the 5th position? Yeah, she has 36 more cards, so she can pick one of those. This is the way in which this 5th position can be filled. What is the possibility of filling the 6th position? She is left with 35 more cards. She has 35 options. What is the possibility of filling the 7th one? 34. 8th one, 33. 9th one, 32. So here we are saying that if she has to just find out, if Ananya has to only find out how many ways she can fill those 9 positions, or the possibility or the tree that we talked about in the past, right? You have certain number of things and you want to fill this many positions, right? So this is a favorable condition for giving all 4 A's to one person, be it me, be it Anya herself, be it Ishwari or Chris. They are the 4 players right now. Yeah. So Ishwari, was I able to explain this time?
Yes,
Okay.
it made sense.
Yeah. So now, with that being the case, the total number of options she has for distributing 9 cards in which one person gets all 4 cards. This is my favorable condition. That will be nothing but 1 multiplied by 36 multiplied by 35 multiplied by 34 multiplied by 33 multiplied by 32. This will be the total number of favorable conditions that in which a group of 9 cards can be made with all 4 A's into it. In simple way, if you see, this is only one way you can pick first 4 cards. Done. Because you have only 4 A's. You put all the 4 A's in here and then you have remaining 5 positions, and that is where you have the option of finding out how many ways you can fill every position, and then you go on multiplying like what we have learned before. Yeah. So this is your total number of favorable conditions. Is this part clear so far, or there are opportunities still? Okay. I got a thumbs up. Anush, Chris, Krisha, Aryan, Ishwari, everybody, Ritika, Ananya. Okay.
Yes.
Sarah, Neil, everybody with me?
Yes, sir.
Okay. All right. Srivastav also has joined. Srivastav, are you able to follow me? All right.
Yes.
So we got the total number of favorable condition is this. Total number of favorable outcome is this. My total outcome is this. So what is the probability? Probability is nothing but total number of favorable condition by total number of options. And hence your probability becomes, what is the total number of favorable condition? This one. 36 into 35 into 34 into 33 into 32 divided by whatever is here. 11 into 34 into 37 into 38 into 40 into 13. Now you guys can play with this and figure out what it will be. Yeah. So anyways, I'm not going to the tic-tac-toe game. I call it tic-tac-toe, right? Like whenever you have so many multiplications to do, you can do tic-tac-toe the way you play with it. So summary of what we did was that if you have to find out a probability of certain event, what you have to find out is what is the number of favorable outcomes divided by total number of outcomes. And here in this case, we found out what is my total number of outcomes. So I'm forming a group of 9 cards with 40 cards. This is my total outcome. If I'm talking about filling in, see, if you have to find out the total number of favorable outcomes, again, you have to look at how many positions you have to fill, and each position you can fill in how many ways, and you go on multiplying them. Since in this case, for filling all 4 A's here was only one option, that's why you have no other choice but to go this way. If you have to find out that, okay, what is the possibility of having 2 A's, then you have to play around with this. You could have find out, okay, I have 4 A's and I have to find out any 2A, and that would have given you ways to find out first 2 positions, and then you would have gone the same way to find out how you fill the 3rd position, 4th position, so on and so forth, and then multiply them all. So is this part clear, understood? easy to follow so far, or there is anything that I have made cryptic for any of you? Yes, yes, Chris.
So also while using the probabilities formula to fill in the total number of outcomes, we use the combination formula like you said. But to find the number of favorable outcomes, is there any mathematical way to write that in?
So basically it'll be a mix and match scenario, okay? So there'll not be any straightforward formula here. You have to always break it down into smaller pieces and then see how do you find those pieces individually and then club them together, right? So here I was saying that when you have all 4 A's, what did I say? Okay, for all 4 A's, that means you are filling first 4 positions with A. You don't have a second choice, you have only one way to do it. And since the order doesn't matter, it's just one way. Had it been that order, when the order matters, then you could have said, okay, factorial 4. But since the order doesn't matter, it's one scenario. Now, after filling the first position, you know how to fill the remaining positions. Same way, I said, if you have to choose what is the probability of getting 2 A's? Now, 2 A's, I went for this option because here 2A, meaning first 2 positions are A. Excuse me. First 2 positions are A, then you have to, how many ways you can fill first 2 positions? It's not one scenario, you have 4 A's actually. And how many ways you can find out 2 card out of 4 is this. And then only 2 A's we are talking about. Then this third position would have been, after you pick 2 A's in this way, then third position, you have to understand that you're not picking up A here because you're talking about only 2 A's. So third position, you have to pick 1 out of 36, 1 out of 35, and you would have gone on till the last position. So you have to break it down. I mean, I don't think there's a straightforward answer to this one. You have to always look at what the question is, how would you organize your solution, and then put the pieces together and come to the solution. Did that make a little bit of sense?
Yeah, it did. Thank you.
Anybody having any doubt? Here, Krisha, Neil, Sarah, anybody? Rehan?
No, sir, I understand.
You understand? Okay. Everybody's clear. Savya, very quiet today.
No, sir, I understand.
Okay. All right. So this is one situation. Now, as I said, all of us want to become rich in no time. I wish I was so very rich that I did not have to work for the rest of my life. And how that will happen? By buying a lottery ticket. Yeah? Or I hope, I wish I had bought bitcoins 20 years ago or 15 years ago. Only 5 bitcoins, that would have been enough for me to get rid of my job. But anyways, coming back to a serious point, we all talk about lottery, jackpot, but that is also pure maths. What is the possibility of winning a jackpot? Is it very high, very low? And how high, how low? Let's look at it mathematically. Yeah. So the way lottery works, right? I mean, they have something called 2 pools of balls. One with number from 1 to 56. Okay, 1, 2, 3, 4, 56. Okay, and they have something called I think mega balls or something like that. Okay, so this is again a group of 46 balls. 1, 2, 3, 4 till 46. What they do is they will try finding out a 7-digit. They'll probably pick 6 or 7 from these two jars of balls, and then whoever, so first 6 positions will be filled from this one and 7th one gets filled from this one. And all that is done in a mathematical way so as to make sure that people like you and me can just keep on buying tickets without winning it. I mean, I have never bought lottery tickets so far. I know I'm not a lucky person. I have been to casinos a couple of times, and every time I went, I have lost $50 to $100, and I know that is my limit. I've never gone beyond 100 because I never win. I just go for experience. So here, in this case also, same thing. There's a mathematical calculation behind this. What they do is, from 1 to 56, the number balls that they have, they randomly pick first 6 balls, and that becomes your number. Let's say here you got 2, then you got, let's say, 34, then you got, let's say, 53, then you got 8, then you got 24, then you got, let's say, 59. And again, no number will repeat because once they pick the ball, they don't go back to the jar. And then they pick one ball from here, which could be one of the number 1 to 46. And that forms the number. Whoever has got the ticket with this number, they end up winning the mega jackpot. Now, you'll say, I just have to be lucky on a given day to win the mega jackpot. Now let's look at what is the probability of winning a number or a lottery. Now look at this. What is the total number of possible outcomes in this case? Can somebody tell me? Again, I'm saying, let's say this is the white jar and this is the yellow jar from where they pick seven numbered balls. First to 6, they pick from here, and the 7th one they pick from the yellow jar. Let's say this is yellow and this is white. Can somebody tell me what is the total number of events, or what is the total number of possible outcomes? So, like I said, probability will always be number of favorable event divided by total number of outcomes. Total number of outcomes. So, yes, Ritika.
So I have a question. So let's say each ball has one number, right? Let's say the number 34. Does it count as 2 places or 1 place?
It counts as 1 place.
Okay. So then the probability will be like there's 6 positions to be filled from the first ball. So 56, C6, and then you add the next probability.
Like this?
Yes, that's for the first position.
Okay.
First 6. And then the 7th one is from the next basket of numbers.
Okay, and that will be multiplying that by 46, right? For every number, this many combinations, correct?
Yes, I think.
Yeah.
I'm not sure.
No, it will be, see, it's always multiplication, right?
Mm-hmm.
If you did not have the 7th ball, this was the total number of options you had. You got 2 balls, so you have two times the option, so you multiply by 2. You have 3 balls here, so that multiplies the option by 3. If you have 4 balls here, you multiply the option by 4, correct? So it's always multiplication. So total number of options for every slot, you multiply that by with each other. And that's what gives you total number of possible outcomes. Like what we saw in the tree structure, right? When we were trying to decide on how to buy a car. Yeah?
Yes, sir.
So you said that this will be, you said 56 C6. So 56 combination 6. Now look at this. This is not 56 combination 6. Why? Because when you talk about combination, the order doesn't matter. But in case of a lottery ticket, it will eventually translate into this. Whatever, right? And this becomes your ticket. Whoever has this ticket with this number wins, not the person with this number. Yeah? So here it's not combination. In case of combination, the ordering doesn't matter, but it will not be C. It could be P. Yeah? It could be 56 permutation 6, because the ordering matters, multiplied by how you will fill the sixth position, and then you have only one option. You can go in 46 different ways.
Yes, sir.
Yeah. Now this is something I had not thought about. Okay, so this is more like an eye opener for me. Let me first go in a simple way, and then we'll try validating if this one holds true or not. Yeah.
Okay, sir.
So everybody in the class here, anybody having any doubt with this? Whatever we have discussed, whatever Ritika explained, whatever I was blabbering about, are you guys with me so far?
Yes, sir.
Okay. Yeah, Ishwari.
I just don't get why there's it's 56 permutation 6. Like, why is there 6?
Let's go back to history. So when you talk about permutation, what does it mean? When I say permutation, if you remember, we said, okay, I have, let's say, 3 chairs, okay, to be filled with 6 people. And who sits first, who sits second, that matters. Then how you can make these 3 chairs, how you can make these 6 people sit on the 3 chairs, or how you can find different ways in which you can fill the 3 chairs. It is going to be 6 permutation 3. These are the ways in which you can pick the 3 people out of 6 for filling these chairs. This is the permutation thing that we have learned before. Okay? And as I said in the beginning of the class, between permutation and combination, only thing that you have to remember is, when we talk about permutation, the order among them matters. In case of combination, just a group of 3 people. ABC is one group. Now whether it's coming as BAC, CAB, CBA, doesn't matter. It's one group. It's a group of 3 people, ABC. That's it. Are you able to relate, Ishwari?
I got that part, but I don't get why it's permutation 6. Like, why would there be a 6?
Okay, because you have this many options to fill this many positions. Okay, so let's
So you get 6 tokens from each wheel?
So here
I
yeah.
didn't know how many tokens there
Yeah, I can take 6 tokens. So there are 6 balls, I will randomly pick one after another. And once I pick a ball, I will not put it back.
Mm-hmm.
So now, I am going to validate this one, okay? This is a recommendation that Ritika gave, and I believe this is right, but we'll validate that also, okay? But is everybody able to follow what we have discussed so far? Rehan, Anush, Vaibhav, Srivatsav, Heer, Savya, everybody? Okay, now let's look at a simple situation. Now let's forget about permutation, combination, all that mathematical jargons. Let's look at a very simple, childish approach for solving this problem. If I have this white jar where I have number 1 to 56, and this is my yellow jar where I have number 1 to 46, first 6 positions or first 6 balls that I'm going to pick for deciding the number for the lottery is going to come from the white jar, and the 7th one is going to come from the yellow jar. Okay, simple, like a child, like a toddler. If I have to pick one, I know that I can pick the first position in 56 possible ways. Agreed?
Yes, sir.
After I pick my first number, I have 55 more options to pick the second one. Yep. I have 54 more options, 53 more options, 52 more options, 51 more options to pick the first 6 balls from the jar, from the white jar. Yeah? And every number I pick up, that becomes my number. for the lottery, for the winning lottery. Yeah?
Yes, sir.
Now, the seventh one, I have number 1 to 46. I have 46 different options to choose from. Yep. So the total number of options I have, total number of possible options that I have for picking up this is 56 into 55 into 54 into 53 into 52 into 51. I'll keep them together multiplied by 46. This is my total number of outcome or total number of possible outcomes. Yeah? And who's that lucky guy who's going to win the jackpot? Will be only one person. Whoever loves doing calculation can do this calculation and you will eventually find out it is going to be 3, 6, 7, 14, 13 digit number. So 10 to the power minus 13 or minus 12, whatever it comes down to. 1 in a billion maybe, or 1 in 100 million chance to win the lottery. That means if you buy million tickets or 100 million tickets, then you might end up winning. So you will end up spending $200 million to win a 5 million jackpot, and you can imagine, is it worth spending that money? Okay. So this is about the jackpot. This is how. So if you look at the calculation, that means if let's say every ticket is worth $1 even, this translates to somewhere around 172 million. I mean, as far as I remember. Okay. So by selling the tickets, by selling every ticket for $1, the lottery company or the state government, whoever is organizing that event, earns this much money, and then let's say gives $10 million a winning prize. There is a motivation for doing so. Instead of me buying the ticket, if I am rich enough, I will have my own lottery company to sell this many tickets and give this much as a prize. Yeah. So this is how the jackpot thing is calculated. We'll go back to the calculation that Ritika was talking about. That will it be 56 P6 multiplied by 46, and we'll see that. The total number of possibility is this one. We'll try finding that out. But before we go there, anybody have any questions so far? I mean, did I explain this in a simple enough way, or it is still not ringing the bell? Arya, Ishwari? Yeah, Ishwari, go ahead.
I also don't get why you have to multiply it by 46. What does the number like?
This, okay, so these are the, see, if you look at all the numbers here, these are the number of options you have. Okay, imagine you did not have the 7th ball, only 6 balls were to be picked up. Now if you had, let's say, 2 balls here, then you are doubling the possibility here. For every combination there could be 2 options. If you had 3 balls to be picked up, then you are further increasing the number of options by 3. I mean multiplying by 3. If you had 4 balls to be picked up, then this, for every combination there are 4 options. So this multiplied by 4. So basically this 46 is nothing but every addition of this thing is kind of reducing the probability for people to win. And that is why there will not be even a jackpot which will say, okay, fine, it's a 4-digit jackpot. Because then it's easy to guess. You know that, okay, there are less contenders and we can just use less. I mean, there's less probability that there's a higher probability to win the lottery. So basically, every addition of the ball is multiplying the number of options. Basically, total number of options, and more the options, bigger the denominator, lesser the probability.
Yes, I get it now.
Now let's go to this one, right? Because Chris was also wanting to know if there's a formula which we can use. So, total number of options, we said, okay, fine. Will it be 56p6 for picking the first ball? What is 56p6? 56p6. It says the number of ways you can pick 6 numbers from 56 options, and where the order matters. So that's why it's permutation. So, here 56p6 is nothing but 56 factorial divided by 56 minus 6 factorial, which is nothing but 56 factorial divided by 56 minus 6, 50 factorial, which will result into 56 into 55 into 54 into 53 into 52 into 51. Up to 50 is taken care. So 51 to 56. This is what you got. So Ritika, whatever you said, it will not be 56 combination 6 because the order matters. If you jumble the numbers, the winner changes. That's why it will be permutation where the order is considered. So we can use this. You have to pick first 6 balls out of 56. You can use 56p6. These are the number of ways in which you can pick first 6 balls, and then multiply that by 46. That will be a total number of options. So you can either do it the way that I explained, that the toddler's way, or you can use this understanding of your permutation for solving this.
Yes, sir.
Yeah. So again, as I said, there's no silver bullet kind of a thing. Okay, you have to always look at breaking down the problem into smaller pieces, and then you see how you put the pieces together to find your solution. Yeah. I hope you guys were able to understand and relate the concepts of permutation and combinations for solving the probability problem. Yeah. So we have kids joining from the junior grades. We still have 1 more minute. So all the kids from level 1, I would request you guys to stay in there for 2 more minutes while we're wrapping up the previous class. Okay. Yeah. So the question to all the senior kids here. Are you guys clear with what we discussed?
Yes, sir.